Hi viewers, I am creating these videos to help teachers of maths support their learners in making sense of mathematical concepts and their associated procedures and processes. And today I want to follow up on my factorization of quadratics video by looking specifically at the factorization of quadratics that are the difference of two squares. And what I would say is if you haven't yet watched the other videos around factorization and potentially expanding as well, then it might be worth starting with those before you come to this. So I have my algebra tiles here to help me, and we're going to look at a difference of two squares quadratic, something like 4x squared minus 9 will do the job quite nicely. And as always, my instruction to learners is going to be, right, so take those tiles, 4x squared and negative 9, and build me a rectangle with no gaps, no overlaps that will use those tiles, and in particular that will have an area that is the same as the value of those tiles. So we're talking about building a rectangle with this area. Okay, and if pupils are familiar with this, and again, depending on how people do it, some people like to set this up using an axis. So we'll have the horizontal and vertical set as an axis. And as I said in my previous video, if you're going to do that, it's worth pupils being very aware of where the positives and the negatives appear in this sort of axis. But if you're going to do something like that, then we can say, right, well, my positive 4x squared can go up here. My negative 9 then will have to go either in this quadrant or in this quadrant, but cannot line up alongside my x lengths. So the only potential places for it to go are here. Oh, don't want to drag the actual axis out of the way. Are here or potentially sort of the same sort of thing, but down here. And so the question is, how can I create a rectangle with no gaps and no overlaps that will fill the space here and that will use this area? Well, the only way, and again, it might take learners a bit of time to sort of play with this, and it might be worth giving them a bit of time to play with this, but the only real way is to put that negative 9 there as a square, and then I can fill this space with some negative x's, but importantly, I can fill this space with the same number of positive x's. And whether you do that like that in the axis, or you again could have done it down here and had my positive x's here and my negative x's here, or whether you just do that as the length and width of a rectangle, and we can see we can do the same thing just setting up sort of a standard rectangle with a length and width. The key to this is because, as we already know, these ones or negative ones won't line up alongst any length involving x, that they've got to be down here on a sort of diagonal from the square point meeting the square point to point, and these have got to be arranged in such a way that the space above and the space to the left is going to be equal, so that I can fill half of that space with x's and then half of that space with negative x's. And then, of course, it's about, okay, well, what is the length and width of this? And using it in this sort of way, it takes a little bit more understanding of multiplication, and particular multiplication of negatives. But if pupils have seen the fact that when we expanded things, if we were creating an entire red block, it would come from flipping the sort of tiles that make that up, then we should be able to notice that this will be 2x and a positive 3. This will also have to be 2x because it's that gives us our 4x squared, and it's the 1 times the 2x and then the 1 times, and in particularly overall the 3 times the 2x that gives us that 6x. But that these will have to be negative, and that's going to be the only way to make that whole row of tiles flip around. So rather than having positive 3 here, having negative 3. And like I say, if you're setting that up as an axis, then I've already explored the benefits and the drawbacks of this. The benefits are that where these positives and negatives appear becomes more apparent because they have to line up with where positive and negative numbers are on the axis. The negative is that the axis ends up splitting the space into 2 parts. So technically, that idea of gaps is not as clear, and not having gaps is not as clear. Okay, but of course, all in the end, we get to the same sort of thing where we've got the 2x plus 3 and the 2x minus 3. But what I'm particularly drawing people's attention to here is the fact that because I had no x's to start with, I needed to arrange these tiles so that the gap here and the gap there were the same size, so that I could fill one of the gaps with positive x tiles and another gap with negative x tiles, creating a total number of x of 0, a total area from the x's of 0, because this is just 0 paired to that. And that's the sort of crucial thing that you're trying to get across in this representation, is that because we have the 0 x's, I'm not going to be able to build a rectangle with no gaps without using some x's, because I can't line anything other than x squared or x's up against a length of x. And so rather than saying, well, I can't build a rectangle at all, it's how do I build it in such a way that the spaces to the right of my x squared and below my x squared, or to 2 of the sides of my x squared, are equal in size. And the only way to do that is to make sure that my 1s, which have to be on a corner with my x squared because they're not going to line up along any of these x lengths, is a square to form a square with those 1s. And if those 1s won't form a square, like if this was 4x squared minus 8, it wouldn't be possible to do that. I'd always end up with different size spaces off the length and width of that rectangle. And so obviously in that case, the only thing to do would be to write it as 4x squared minus 2. So that is my short video on using algebra tiles to support sense making of factorization of a quadratic using difference of 2 squares. As always, I'd like to say a big thank you to mathspot.com and its creator, Jonathan Hall, for providing this fabulous website where we have not just the manipulatives, but we have this wealth of other materials and other tools that we can use to help learners and to support teachers, and that teachers can use to help learners with their mathematics. And there's a huge amount of material on there. If you haven't been to that website yet, then I don't know what you've been doing, particularly if this is not the first video you've watched, because I say it every time. Please do make sure you go on and have a look at that website. It is fantastic. There is so much there to be gained for you in working with your learners. And as always, if you are interested in looking more at manipulatives and visuals and using those to help learners with making sense of maths, then do pop along to my website, visiblemaths.co.uk. And among the many things you'll find there, you will find a link to my book, which is also called Visible Maths. The publisher for that is Crown House Publishing, and there's a link to their website on my website, where you can view some sample pages of the book, and if you feel like it will be useful, you can place an order. I will be creating these videos throughout lockdown, potentially beyond. So if there is a particular concept or process that you feel like you would want to see modeled using manipulatives or visuals, then please do get in touch and I will do my very best to make one for you. Thank you very much for your kind attention.